The lesson outcome for this video is, I can solve linear inequalities by graphing. Before we look at the steps for graphing inequalities, we're going to do a little practice telling whether a given point is a solution to the inequality. We've done this with equations before. What we're going to look at is this point right here a solution of the inequality? In other words, if we put this value right here in for x, right here, and we put this value in for y, is it true or false? If it's true, it is a solution. If it's false, it is not. All right, I'm actually going to use blue for my x here. I'll change that. All right, so we're going to go ahead and put 6 in for x and 3 in for y. So we're going to put the 3 here for y is less than -2. Our x value is 6, and then plus 4. Okay? So we simplify on the right-hand side, and we're just going to leave the 3 the same all the way on the left-hand side. So this 3 is just going to stay a 3. 3 is less than. -2 times 6 is -12 plus 4. And then we keep going. 3 is less than -12 plus 4. -12 plus 4 is -8. So now the question is 3 less than -8? Since 3 is positive and 8 is negative, -8, we know that 3 is not less than -8, it is greater than -8. So since this right here is false, we know that 6(3) is not a solution. And we'll use that later when we're graphing. Let's try one more. Let's put 4, -2 into this inequality and see if it is true or false. So we'll start with putting in -2 for y. So -2 plus 2 is greater than or equal to 1/2, and our x value is 4 plus 3. All right, we're going to simplify. -2 plus 2, this is 0. That's okay, 0 is a number. Is greater than or equal to 1/2. We're going to leave it the way it is and do our parentheses first, as our order of operations tells us to. 4 plus 3 is 7. Half of 7, this stays 0, is greater than or equal to, half of 7 is 3.5. 3.5. So again, is our inequality true or false? Is 0 greater than or equal to 3.5? Once again, 0 is not greater than 3.5. It's not equal to 3.5. So this is again false. And 4 -2 is not a solution. Okay, so here are the steps for graphing a linear inequality, and we'll be doing this on a coordinate plane, which is different than graphing the inequalities we've been doing on the number line. So you might want to pause the video and jot these things down. Step 1, make sure your line is written in a graphable form, or make a table to graph it. And we'll remember our graphable forms are like slope-intercept form, or standard form, or point-slope form. Step 2, we're going to graph some points. Step 3, we're going to decide if our line is going to be solid or dashed. And the way we know this answer here, solid is just like we did with the circle, whether we shaded it in or not on the inequality number line. Again, the line is going to be solid if it's greater than or equal to, or less than or equal to. It's going to be dashed if it's simply greater than or less than. Then we're going to plug in a point, and we're going to see if it makes our inequality true. This right here, this step, is what we were just doing on the previous slide. We're going to check that, use that information again to check. So if it's true, we're going to shade on that side of the line. And if it's false for that point, we're going to shade the opposite side of the line. That will make more sense after we look at a couple of examples. Our first example is graph the solution of y is less than -3x plus 6. So first of all, what form is this in? Hopefully you remember It is similar to our slope-intercept form. It is our slope-intercept form. The only difference is that the equal sign has been replaced with a less than sign. All right, so slope-intercept form. And if it's in slope-intercept form, the best way to graph this is to find the slope and to find the y-intercept. Remember that our slope is the number in front of x. So m is -3. And our y-intercept is this number over here. So b equals 6. We're going to begin at 6. So on the coordinate plane, I'm going to go ahead and draw a point right there. 6 on the y-axis. Now we're going to use our slope and we're going to move. Notice -3 means down 3 and then right 1. So from that point, the blue point, we're going to go down 3, 1, 2, 3, and right 1. This is the point that we will graph next. Now I'll just go ahead and draw a line through that. Oh, let's pause. Sorry. Let's not draw a line yet. This is an important step right here. Is your line going to be solid or dashed? And again, if you remember from the previous slide, it's solid if it's greater than or equal to or less than or equal to. And it's dashed if it's just greater than or less than. So since this symbol right here is less than, it's going to be a dashed line. So we're going to graph a dashed line. Sorry. It's actually pretty tricky to do on this iPad here, sorry. Through those 2 points. Now what we have to do is we have to decide where to shade. And what this shading does is it tells us where all of the solutions for the x and y values for which points will be true for this inequality. So are we going to shade over here on this side of the line that we drew, or are we going to shade on this side of the line that we drew? That's our question right now. Because either this giant set of points, and of course anything infinitely in all these directions, or this giant set of points this direction, one or the other is true for this inequality. So we want to plug in a point. And I'll tell you, the easiest point to plug in, if it's possible, is the origin. Now remember, the origin is the point at 0, 0. So this point right here, 0, 0, is the origin. And it's easiest to check that because zeros are really handy to work with. So I'm going to go ahead and put 0, 0 in for my inequality. I have y is less than -3x plus 6. I'm going to put a 0 in for y. I'm going to put a 0 in for x. And we're going to simplify. So this is 0 is less than -3 times 0. This right here becomes 0. So then we have 0 plus 6, which is 6. So 0 is less than 6. The question is it true or false? Well, 0 is less than 6, so it's true. All right, which means we shade where that point 0, 0 exists. Since that point is right here, we're going to shade on the side of the line that this point exists. So our shading of our graph is going to be on this side of the line. That means every point in this region, including extending it beyond, by the way, in all directions, all of those points will be true for this inequality. Okay, let's try one more. Go ahead and pause the video and try it on your own and then check back to see how you did, or just feel free to watch another example if you feel the need. What form is this equation in? Actually, it's in inequality, sorry. It is in point-slope form. Hopefully you recognize that from all of our graphing practice. Point-slope form, remember, that means we want to find the point and the slope from the equation that helps us graph it. So the point is found by using the opposite of this x value over here, so -1, and the opposite of this -7 here, so +7. And the slope is -2, or -2/1, because the slope is found right there. I'm going to graph my point, -1, 7, which is right here. And I'm going to use my slope to go down 2 and right 1, and I will get to this point right here. Now, we're so used to just graphing the line right away. Make sure you answer this question. Is it solid or dashed? Is it greater than or equal to, less than or equal to, or is it greater than or less than? Notice it is less than or equal to, which means it is a solid line, because it means that this can be equal to this, and it'll still be on the line, and it'll make it true. So it's going to be a solid line through those 2 points. There we have it. And once again, we need to now plug in a point to our inequality and check to see if it's true or false. Now again, the easiest point to use is probably 0, 0 every time. But just to show you that we can pick any point anywhere, I'm going to go ahead and pick a different point. That is, again, make sure it's obviously on one side or the other of the line. So let's say I want to check this point right here, 5, 5. I'm going to go ahead and put a 5 in for x and a 5 in for y. Again, you don't have to pick one that has the same number for x and y, but that has happened on both of my examples. All right, so let's put a 5 in for x and y. There's my inequality. I'll put a 5 in for y. And I'll put a 5 in for x. And I'll check to see how this looks here. 5 minus 7 is -2. And then we have a -2 here, and 5 plus 1 is 6. So now we have -2 is less than or equal to, and then we have -2 times 6, which is -12. The question is this true or false? Is -2 less than or equal to -12? Well, that is false. Okay? -2 is not less than -12. -12 is less than -2. Since this is false, we need to shade away from this point, the other side of the line. So I'm not going to shade up here where that point exists, because we just found out this point is not a solution. So we need to shade all this other space over here. There you go.